Hello and welcome to this video. In this video, we're going to discuss about linear regression and gradient descent. Let's first see what a linear regression is. So linear regression is a basic and commonly used type of predictive analysis. The overall idea of regression is to examine two things. One, does a set of predictor variables do a good job in predicting an outcome or a dependent variable? And two, which variables in particular are significant predictors of the outcome variable, and in what way do they indicate by the magnitude and sign of beta estimates impact the outcome variable. These regression estimates are used to explain the relationship between one dependent variable and one or more independent variable. The simplest form of regression equation is with one dependent and one independent variable, which is also called a univariate linear regression. The major uses of regression analysis are, for example, determining the strength of predictors, forecasting an output, and trend forecasting. The main intuition behind linear regression is the concept of gradient descent. Let's see what a gradient descent is. So gradient descent is an optimization algorithm used to minimize some functions by iteratively moving in the directions of the steepest descent as defined by the negative of the gradient. In machine learning, we use gradient descent to update the parameters of our model. Parameters refers to coefficients in linear regression and weights in neural networks. Consider the three-dimensional graph below in the context of a cost function. Our goal is to move from the top of the mountain in the top right corner, which we can also call the highest cost, to the dark blue in the bottom left, which we can call the low cost. The arrow represents the direction of the steepest descent from any given point to the direction that decreases the cost function as quickly as possible. So starting at the top of the mountain, we take our first step downhill in the direction specified by the negative gradient. Next, we recalculate the negative gradient, passing in the coordinates of our new point, and take another step in the direction it specifies. We continue this process iteratively until we get to the bottom of our graph or to a point where we can no longer move downhill, a local minimum. Now the size of these steps is called a learning rate. With a high learning rate, we can cover more ground each step, but we risk overshooting the lowest point since the slope of the hill is constantly changing. With a very low learning rate, we can confidently move in the direction of the negative gradient since we are recalculating it so frequently. A low learning rate is more precise, but calculating the gradient is time consuming, so it will take us a very long time to get to the bottom. A cost function or a loss function tells us how good our model is at making predictions for a given set of parameters. The cost function has its own curve and its own gradients. The slope of this curve tells us how to update our parameters to make the model more accurate. In the next video, we'll dive deep into linear regression and we'll see how we can implement linear regression in Python. See you in the next video.